This is Kelly Hill, technology reporter for RCR Wireless News. I am here at the 5G Innovation Summit with Jeremy Cline, who's a product manager with Rohde Schwarz. And you've been doing some of the technical sessions in the tracks about field testing for 5G.
Correct.
And how things are going to be evolving, what you're seeing in the field, and then how you guys have been addressing some of the equipment needs on that side.
Yes.
So let's talk a little bit about the key takeaways in terms of how field testing is evolving in 5G.
Okay, sure. Yeah, so basically this all started with Verizon. They came out with their pre-5G standard, if you will, 5G TF, and they needed a way to do coverage prediction, right? So they would go out with the infrastructure vendors and they have these CPEs that they want to figure out where they're going to put it in, say, an office building or even someone's home, and you don't want to be in there very long. So you need a tool that allows you to make these coverage heat maps of where you actually get that signal. And so we set out to build something like that, and we did.
Okay. So tell us. So you guys basically used some FreeRider pieces, right? And
Yes.
so tell us. So FreeRider is your backpack setup that has, I think it can hold up to 6 smartphones, and there's a scanner on the bottom.
Yes.
And so, but what you showed us in the session was actually pretty significantly different, even though it fits into the same physical footprint.
Exactly, yeah. So it's based off of our FreeRider 3 platform, and you were correct, yeah. 6 smartphones and a scanner inside. So basically stripped everything out of the core box, and we put the scanner back in, and we had to add a down converter so we could go up to 28 gigahertz.
Okay.
That has to be driven by an LO board, so we put that in there. We left the battery pack in there. So there are 4 batteries. It gets you about 8 hours of battery life. We think it might be a little bit longer. We haven't tested it yet. But yeah, the scanner that's inside is the TSMA, and it has a built-in PC, so we're able to install our Romus drive test software on there. We made some special 5G views that allow you to look at some of the parameters for 5G TF.
Okay. And then there's an antenna that basically comes up off of it,
Yes,
which
yeah.
I thought was interesting.
Yeah, exactly. We literally went down the street to Home Depot and bought some PVC pipe and put the Omni antenna up on top, and that's to avoid any kind of body fade, and that's why we did it. But it works. It gets the job done.
And you guys address drive testing too, right?
Yes. You can replace the omnidirectional antenna with a horn antenna or any kind of antenna that you want to put on top, as long as it goes into the SMA port on the scanner. And we've done that. We usually use a tripod, and we could put it out through the sunroof and point it toward the base station, or just drive around and take measurements, whatever you like. It's a fairly flexible thing.
Okay. So some of the things that you talked about were some of the challenges for field tests when it comes to 5G. One of them being because when you start talking about millimeter wave, you're thinking about passive objects instead of active signal generation.
Right.
In terms of interference. Can you talk a little bit about some of the other issues that you see out there?
Sure, absolutely. So along those lines, back in the pre-5G days, mostly with 4G LTE, you weren't worried about traffic signs or those big, large metal signs you might find at shopping cart returns or something like that. But with 5G, that's different, right? So when you're up in millimeter wave frequencies, 28 gigahertz, 39 gigahertz, and beyond, you have to worry about these kinds of things. You worry about foliage and rain and snow and things that we were worried about before, but not as much, because the free space loss and all the physics of having signals up in those frequency ranges, you have to worry about that kind of thing. So that's there, and another one that we discussed in the class was the idea of network densification.
Yes.
Right? So if I'm standing at a gas station and I see this little spike coming off the pump, which is all over the place in the real world, it's important to realize that may not be interference until you have a negative effect.
Yeah.
But you have to worry about that now with 5G, because with the whole idea of network densification, you have a lot more small cells closer to each other. That's in addition to all the thousands of base stations we already have, right? So since they're more spread out through the geography and you just have more base stations, you might be able to pick up one of those stray signals, so now you have to worry about all those weaker interference or potential weak interference issues. Yeah.
And you guys also took kind of an interesting approach, I think, to addressing the fact that there's so much wider channel bandwidths in 5G. So up to 100 megahertz, and but most standard test equipment now only goes up to 20 megahertz channels.
Exactly.
So talk a little bit about how you guys tackled that problem.
Sure, yeah, absolutely. So the maximum channel bandwidth for LTE is 20 megahertz. So it's no surprise when you look at scanners and a lot of spectrum analyzers too, that 20 megahertz is kind of the standard these days.
Yeah.
Well, you look at 5G TF and probably other standards that will come along, it's going to be at least 100 megahertz. I know that's the case for TF at least. And so if you want to be able to see the spectrum signature, for example, and you don't have a piece of equipment that goes that wide, what do you do? So for us, we use these fast tuning algorithms that allow us to look at simultaneous technologies and bands. That's how we get away with doing that now. And the TSMX scanner line, we've had that for years. So we can just utilize that and take 5 20 megahertz chunks, for example, down an IQ, and then just stitch them together so that you get a 100 megahertz picture.
Okay.
So if you're willing to wait a second or less, it's not very long, then you can get the 100 megahertz picture that you need.
Okay.
Yep.
Okay. Great. Well, Jeremy, thanks so much for your time.
Yeah, thank you. Thanks for coming.